Good. So today's topic is OpenBIM and IFC. This is an important topic because this is about collaboration. Okay, so we'll talk about interoperability, why it's an issue, why it's a problem, and we'll define OpenBIM. We'll talk about IFC and also how IFC is used. Okay. Now, if you want to collaborate with other partners, I mean, as I mentioned many times before, in the construction industry, we are not alone. There are engineers, there are specialist designers, there are consultants, there are many different parties. And basically, we have to be able to exchange rich building data. But the problem is, there are a wide variety of software platforms. Okay, so we want to use universal open standards to be able to collaborate. Okay, first we will talk about why working on a single software wouldn't work. Okay, in the construction sector, and why we need to have a way to provide long-term, let's say, project collaboration, and how OpenBIM is proposed, and which is using a new vendor-neutral standard. Okay, and then we'll talk about IFC. It's an ISO certified data schema, which is used to structure and transfer building geometry and properties. So we'll talk about that. As you can see, there are many different software platforms. We have like Revit, ArchiCAD, Tekla. We can use these to use IFC. IFC is the PDF of, let's say, of construction industry. And we can use like VCF, we can future-proof the data, we can use COBie for management. So all these are related to OpenBIM concept. Okay? I think I'll talk about when the time comes, like PDF. Now, there are many specialists, okay, in the construction sector, but in the traditional terms, the software that we use basically lock ourselves into that software platform. Like Revit, we use RVT project files, right, or RFA family files, but they are locked. You cannot use a Revit project file directly in ArchiCAD, for instance. So in that regard, the software that we use basically lock us into isolated, disconnected digital silos. For instance, one office could be using Revit, the other office could be using for structure Tekla, okay? Or another office could be using, like interior designer, they could be using ArchiCAD, okay? So this is a problem, and the sector is highly fragmented. Here it says each new decade brings new specialist disciplines and trades. What does this mean? As we go along in time, new professions appear. Okay, like when I was a student, probably there was no field like building security specialists, maybe, or I don't know, right? Maybe data security specialists, which are employed in buildings. Or FM was not heard of in Turkey, for instance. Okay, so we have many new disciplines appearing. Like when I was a student, facade consultants were very rare. But today it is a given. Like you have to have a facade consultant. They help you with your building. And to perform these people, like architects, structural engineers, mechanical engineers, specialists like a facade designer, or let's say security systems designer, they use their own highly specialized proprietary software applications. Like acoustic engineer, they have their own software, okay? Or building services engineer, they have their own software, okay? And the software basically creates isolated data silos, okay? So like that. So they all work in a jar, and their work is stuck in these jars. Okay. So we want to get out of it. Okay. But if we get out of it, the problem is that they're using different software. How do we, work together? They could all be working with BIM-capable software, but their software could still be different. Okay? Like Tekla is BIM-capable, but it's a different software. ArchiCAD is a BIM-capable software, but it's different when compared to Revit. Okay? So these people are working with their own software, but how can they work together, especially if we want to achieve a federated model? We mentioned federated model in the last weeks, right? So we want to bring together different aspects of the project in one three-dimensional space. And how does it work? And how can we run virtual clash detection, for instance? Okay, so this is the issue. And this is not just inconvenience, but also it costs money. This is always mentioned in BIM. Okay, in 2004, the US National Institute of Standards and Technology, they conducted a study to figure out how much different software, use of these different software packages cost the US construction industry. At that time, it was costing like 15 billion US dollars. Okay, so the reason is, if you have many different software between different people, and if you are exchanging data in terms of like paper or PDFs, okay, then there is redundant data entry. Everyone has to, like, if the architect gives their project to the structural engineer, in their software package, let's say Tekla, okay, they would be, if they are not transferred by digitally, they are basically entering the data again. Okay, so this costs money, and it's basically an inefficient business process. And also, when you have this inefficiency, you have to hire more people, okay, to do the job. The job will not be a good job, and you'll be paying money for a not very good job. Okay, so this is the issue. So yeah, it's basically manual data re-entry. This is a big issue. We don't want to do that. We don't want to enter the data again and again. We want the data to flow from one professional to another. Okay, so basically we want the information to flow freely. Of course, inefficiency in business process, there is delay because we're waiting, okay, for the data to be entered. So it costs a lot of money, and owners pay for it, okay? And the issue is that if you don't have interoperability, what happens is that if you can still use Revit, okay, but if you're not using interoperability, the outcome of Revit goes to the next person as a degraded two-dimensional PDF or paper. Okay, so this is loss of information. We don't want to lose information, right? So basically, as a result, each receiving party re-enters the data. So this is the problem, right? So you have a wonderful model, you put it into the funnel, but it's crushed into a two-dimensional flat drawing. So what's the purpose of doing that then? Okay, like we have wonderful, this is the issue in Turkey now. Many offices are using Revit, but they're only using it because Revit is convenient to use, okay? At the end, they print out a PDF file or, a paper file, and they give it to the engineer like that, okay? So this is not BIM. This is only using Revit, okay? We are not interested in using only Revit. This course is all about this whole continuity, okay? So this course is not a Revit course, okay? Revit is only one tool that you have been learning how to use, but in reality, if you only use Revit, this is going to be the outcome. Just a PDF file, just a drawing file. It's going to be good for your office, okay? Because you can easily make changes and your drawings are automatically generated, etc. But this is not what we intend to do, okay? We want to be able to, that this engineer is not happy because this engineer has received a two-dimensional paper, and they are trying to enter this model into their project file, okay, in Tekla. So this is not what we want. So the other issue is the long-term accessibility, okay? So why is this an issue? Buildings, we expect buildings to last for many decades, okay? Like this building is 60 years old, right? So, and we don't have the original drawings. We have only copies of the drawings, okay? I don't know, maybe the original drawings are with the son of the architect who is still, practicing. But if this building was drawn on CAD software in the 1960s, but there was no CAD software, of course, at that time. But let's say if this building was drawn in a CAD software in the 1980s, okay? It would be stored on a format which we wouldn't be able to open and maybe investigate. Okay, probably on a tape or a hard disk which is already broken or etc. So the data retention is not good. So and proprietary exchange formats like Revit or ArchiCAD PLM file. They're locked into specific vendor ecosystems. Okay, so the Revit file can only be opened in Revit. Now the issue is, buildings live long. We don't know if there will be Revit in year 2050. Okay, maybe they will go bankrupt. Okay, so what's going to happen then? How can we sustain the model into the future? So this is an issue. Okay, so. Maybe there are some software, and I'm not. I shouldn't be saying maybe. There are many different CAD vendors in the past who have already disappeared. Okay, so the files created with these software we cannot open them. Okay, so we don't want to rely on a proprietary software environment. Okay, so we want to be able to, let's say, use that data, the digital data, in the future in some ways. Okay, so this is the issue. And software cycles expire every few years. The old versions can potentially be unusable. Okay, so we need open standards for digital survival. So we need open descriptions of the software. Like Revit, it's a closed system. Okay, only Revit software can read these files and make meanings out of it. It's a closed ecosystem, or ArchiCAD. So we need a digital lingua franca. What is lingua franca? Lingua franca was like in the 18th century, at the end of 18th century. Okay, the common language for countries was French, and the British were learning French, Ottomans were learning French to speak in French, okay? So all international institutions were communicating in French. So this is called lingua franca, common language in French, okay? Of course, French lost their influence, so this has become English. Today, it's all English, right? So similarly, we need a lingua franca, a common language for our sector. Okay, for construction. So, because we have fragmentation and we have data loss, instead we need a universal open standard to translate information across different software platforms. Okay? So, what we found out was that we cannot have a homogeneous software environment. We cannot have Revit everywhere. Okay, we cannot have everyone using ArchiCAD or AutoCAD or whatever the software is. Okay, this is not possible because it's a free economy, right? So whoever makes it better, they will survive. Okay, so we don't want to have that imposed on us. We want to use, because if it was Revit, then Revit could charge us whatever they want. And actually it is like that. It's not Revit, but it's the de facto, let's say, common software. And they charge more and more every year. It's becoming more and more expensive. It's a big issue. So, so we want that to happen, okay? We want a lingua franca, a neutral common language where distinct systems can exchange complex geometric and alphanumeric data. So we want to be able to exchange complex geometry, complex alphanumeric data by means of a neutral common language, okay? So this is where we lead to OpenBIM. So we need a universal approach to collaborative design based on open standards and workflows, like open way of working, okay? So yeah, like you have Revit, for instance. It's a closed BIM, proprietary platform, but you can switch to open BIM from Revit. Vendor B, like again, vendor C, the different design, construction, facilities, so you have different vendors for software, and you want to be able to switch from one data format to another easily. So it's a universal translator, it's like PDF. Now, let's get back to PDF. Do you know what PDF is? Portable document format, PDF. Why is it portable? It was the same problem in text editors when I was a student. Like, okay, PDF appeared when I was a student. At that time, we were using Word, Microsoft Word, but there were many other also editing software. But there were also many digital, let's say, two-dimensional design software, like Adobe Illustrator, CorelDRAW, many different software, okay? Now, the issue was, you create an output, like you have a Word document, you create a Word document, and you send it to someone, okay? The problem is, that person should have a similar version of your Word to be able to see the document as you see. Okay, but we cannot, push people into using Microsoft Office, for instance. They can be using OpenOffice, for instance. Okay, or they can be using LibreOffice. Okay, so it's not fair. You cannot say that go buy Microsoft Office. Even within Microsoft Office, Mac version and Windows version were not displaying the same document. They couldn't do that. So, what did they invent at that time? They invented Adobe, I think it was Adobe who invented it, but they said that, well, we have many different software, and they generate text, images, vectors, pictures, drawings, etc. in a sheet. Why don't we standardize this output in a document which can be read by everyone? And this means that PDF is the outcome. So, some people look for PDF editors, etc., to make changes to a PDF. You're not supposed to make a change to PDF. I mean, you can make some little maybe corrections, but even that is not this is not a very good idea. You want to make the change to the original Word file, if you want to make that change. Okay, PDF is only a copy that can be seen by anyone with free software. Okay, so this is why, the forms are all in PDF. Why? Because the PDF file can be opened by anyone. It's safe. You cannot put harmful code into the PDF file. It can be opened by anyone. Okay, so in the word editing, word processing, let's say, field, this was the issue. So similarly, we want to have a neutral, readable, writable software data, let's say, formats for construction industry. That's OpenBIM. Okay? As a result, we can put them together and we can check for clashes. We can have data flow through the life cycle, and that data can be read easily in the future. Okay? So, let's define OpenBIM then. So, we say that it's a universal vendor-neutral approach to collaborative design, realization, operation of buildings based on open standards and workflows. So, what does this mean? We say open standards and workflows. Basically, we don't want a proprietary software format, so we want to have open, freely shared standards. Okay, and with OpenBIM, we have model-based approaches like IFC, which we will talk about, how the model is created. And also process-based approaches like ISO 19650, which this course is based on. So ISO 19650 is also OpenBIM. Okay? So this means that with OpenBIM, we are not only interested in the file formats, let's say, neutral files between software, but we are also interested in the process. How do we run this information creation process? Okay? Remember, from the very beginning of the semester, I've been showing you how we are doing, like how we create a common data environment, or how we have different parties doing similar, working towards a common future, how we have different, let's say, labeling of models, okay? So this is what it's about, okay? So basically, as a result, we are not focusing on the software tool, okay? Software tool is only a tool, okay? So you can use Revit. Maybe next year you're going to use Bentley, Microsoft, or maybe you will be using ArchiCAD. For your, whatever your project is, whatever your business interests are, whatever the client is requesting, you switch to that, okay? But the idea is accessibility and usability of building data across its entire life cycle. So we want to make sure that whatever software platform we use, we want to achieve accessibility and usability of that data that we generate. Okay, so we want to work together with the rest of the stakeholders to achieve that. Okay, so that is the idea. So it's, of course, beyond 3D, multi-dimensional database, lifecycle connectivity. We bridge the software gap between different software, and we can do real-time simulation and analysis. So all this is based on OpenBIM for the whole world. Okay? So single source of truth. So what are the guiding principles? Interoperability, flexibility, and long-term sustainability. So these are what we are trying to achieve. Interoperability, ability to run, the ability to exchange the data and information across different platforms. Okay, this is important. So you should be able to bring out the building data from Revit and give it to ArchiCAD, for instance. And the ArchiCAD should be able to use that data to continue modeling something. Okay? Or you should be able to bring the data back from TechLab to Revit so that you know what the structural, let's say, changes are from the structural engineering. Okay? So we want reliable data exchanges, okay, and we need independent quality benchmarks for that. So basically, this is provided by some institutions. It's nothing to do with us. And of course, long-term interoperable data standards, okay? So we want to have somebody thinking about that and providing these data standards. And I'll talk about who that is. So that project data remains readable and accessible decades after it is built. Okay, so there will be some people who will be making sure that our data from 2020 is usable in 2050. Okay, so they are basically maintaining that. Yeah, so BIM, architecture of collaboration, we have interoperability, we have flexibility, we have sustainability, we have all these things, we have open standards, we have, we can do parametric design, rapid iterations, seamless data exchange, optimization, etc. So all these are with the OpenBIM. Okay, OpenBIM versus closed BIM. What is a closed BIM then? Well, if someone is using a specific proprietary platform, okay, that's closed BIM, and if they are not basically intending to exchange data. But the problem is that this is not used. So, to be honest with you, every BIM-capable software aspires to be open BIM. Okay, they were closed BIM in the past, but now they are aspiring to be open BIM. Okay, so we want to completely remove restrictions on project participation between different parties. So this is what we are trying to achieve. It's like internet.
Can we say that Frankly use closed BIM because it's programmed?
Good idea. Yes, yes and no. It was a specific program that he developed, but he always tried to make it an open software later. So they used Katya to start a new, let's say, software for their own needs. And it was as they continued, they converted it into something open. So it was closed at the beginning, as you just said. But for instance, when the time came to Walt Disney Concert Hall, they were utilized. They got many consultancies from, let's say, University of Stanford University. Okay, there is Martin. What was his name? Martin something. He was the advisor of my advisor in the U.S. And he basically consulted them with that change. Okay, so yeah, closed BIM is where we are proprietary lockdown, but with open BIM we can exchange data. So most of the industry is already switching to open BIM. Okay, so this is how it works with that. And native authoring. So this is another issue. Now, just because we want it to be open doesn't mean that we cannot still work in the closed environment. That's a native environment, okay? So, how can I say that? Well, let's say you're working in Revit, right? In Revit, you can create many complex project elements. There are many different flexible options. Similar in ArchiCAD too, there are many different ways of creating your objects. But when you create the open exchange format, like the IFC format, it's like the PDF. A lot of things are lost. Think of like your Word file, you make changes, you create a PDF, you still save the Word file, right? You give the PDF to someone else. That person looks at the PDF and they're like, well, can we change this text a little bit? Can we add this paragraph, etc.? So do you want to do it in PDF? No. What do? You go back to your Word, Microsoft Office, or Google Documents, okay, or OpenOffice, whatever you're using. So you're still using that environment. You're still using Revit. Okay, so this is what we call the native BIM environment. So if you're using Revit, it is your native BIM environment. But you should be able to exchange your model with other people. Okay, so we'll get to that. Basically, in an open BIM process, the process is officially initiated when the designer exports and exchanges an IFC file from their native tool. So your Revit model, you think it's okay, you think it's ready to be exchanged with the structural engineer, and you export an IFC file, the PDF of BIM, okay? Then you have started the open BIM process. And the thing is, the way it works is, I don't know if I have a slide for that. Yeah, native BIM Revit, so you give it to them. And this is when the open BIM starts. Okay, so in the closed BIM environment, like your native BIM environment, you make the modeling process. When you change, you make the stairs, you make the, you create the columns, windows, etc. So you create a wonderful model. And once you export, the open BIM has started. It's collaborative environment. Okay? And it is good because with this, with the open BIM or an open ecosystem, okay, so we have another benefit is we can protect the intellectual property. So this is another nice thing. It can enhance the collaboration and also provides a stable foundation for the long-term asset management for the project. So it's a common language and alignment, of course, through international standards, right? We have a common data environment where we develop new workflows, custom applications, technological automations, and without the proprietary lock-in, we retain the ownership and control of our data, okay, instead of a commercial software vendor. This is not very realistic actually, but still, I'll get to the intellectual property, I think, later. So we have the common data environment where we have work in progress, shared, published, archived, let's say stages, gates of the project files. We hold the ownership of the model. Now this is the thing, okay. You have your Revit model, okay, but you don't want to give your Revit model to someone. So you just give a PDF file to that person with the open, okay. So the IFC model is more abstract compared to BIM model, Revit model, okay. They cannot change it. They cannot make big changes into it, okay. Actually, they cannot change it. We don't want that. So it is, in that regard, this was always questioned with BIM. Who is going to own the model? The thing is that you own your own Revit model, okay? No one can access your Revit model. You have it in your server. But when you exchange IFC model. Of course, sometimes some projects, they request Revit models. It's up to their, let's say, initial agreements. We will talk about that in the upcoming weeks. But at the end of the day, we have the opportunity to share just the PDF copy, which is the IFC copy of that model. Okay? So what is IFC then? So let's talk about IFC. It's an international standard data schema. Okay? ISO 16739. Okay? Where we have a universal non-proprietary language for the built environment. It was developed by Building Smart International. Building Smart was started as American Alliance for Interoperability in 1990s, if I'm wrong. I had a slide of that, but I don't have it anymore. Then the Autodesk was in it. Then it was only like 8 big companies in the US who started that formation. Then it became International Alliance for Interoperability, IAI, okay? So that was led by many important companies around the world to, let's say, to agree on a standard data format. Then they changed their name to Building Smart, okay? In Turkey, we have in every country, we have chapters of Building Smart. In Turkey, chapter of Building Smart is organized by İMSAT, İnşaat Malzemeleri Sanayicileri Derneği. Okay? It's funny, I mean, it's not the Chamber of Architects, it's not the Chamber of Engineers or whatever, you know. It's the building materials industrialists who decided on taking that. And they're doing a good job. They have many different work groups. I also perform in some of their work groups. And they basically, the Building Smart International, and one of my friends from when I was in the US, when he graduated, he started working for them. So they are the ones who decide on what the data schema should be like, okay? Because the thing is that data schema changes in time, okay? They have many versions. So they are it's a non-profit international organization. And they make money by giving certificates, by the contributions from companies, so that they can perform. Okay, and also volunteers, like I'm a volunteer. Okay, so it's an open, neutral, and publicly documented standard. IFC. It is like the HTML of architecture or construction industry. You know what HTML is? Hypertext markup language. So when internet was born, okay, it was only a relatively large network, okay? So when I was a student like you, or maybe a few years before when I became a student here, Tim Berners-Lee, what was his name? The inventor of World Wide Web. Tim Berners-Lee or something like that. So a Finnish person. So in CERN, okay, the particle accelerator in Switzerland, they invented, Tim Berners-Lee, right? He invented a system where there could be pages that are linked to each other, okay? he invented it for their physics experiments so that they could store documents in their servers so that everyone can switch from one document to another. Okay, so just like Word Wonder. And then this was very successful. They said, that why don't we use it across the world so that everyone can have their own pages? And the common language for these pages is HTML, okay? Hypertext Markup Language. And the idea is that there is text, and the text is marked up with hyperlinks, okay? So in the text you have a link, you click on it and you go to another document. You click on another document. When I was a student like you, we were writing the pages by just codes, okay? So there was, at the time, the page, the software that was used for page creation was created later. At the beginning, we were using Notepad, just Windows Notepad, and writing our code for the page. And in that page, you can create tables, you can insert images, you can insert links. The code is very simple, HTML, okay? You can read it, understand it, and then make changes and publish it. When you publish it as a HTML file in a server, and your browser, at that time it was Netscape Navigator, okay, the most common one. Then came Internet Explorer, then of course Google Chrome, etc. Today we're using many different software for that. But there are many different software packages, Chrome, Safari, Firefox, they're all using HTML to be able to read the pages. Pages all appear similar in different software environments, okay? So it's a bridge. HTML is the bridge, the data to the browsers. IFC is like that. IFC is a neutral format like HTML. We have OpenBIM, the building data, that is converted to IFC and is transferred to different software packages like Revit, ArchiCAD, Tekla. Okay? So 3D geometry, properties, etc. So basically, IFC, just rather than being a simple file format, it's a highly structured filing system or container where we organize the 3D geometry and the alphanumeric data. Okay, so that different computers can work together. So that was the idea. So Building Smart is the organization, as I mentioned. So here, it's not seen very well, but you can see here better. So you have IFC versions. See, IFC version 4.0.2.0 was retired in 2016. IFC 4.0.2.1 became official. 2018. Now we have 4.3.2. This is ISO, and also we have the ISO standard for that IFC model. Okay, IFC schema. This is what we call a schema. Okay, how we represent the data, and this is the latest official one. IFC 4.4 is currently in planning. And in planning phase, IFC 5 version is being developed, under development. So they are, and why do we need new IFCs? Because building sector is developing, there's new materials are appearing, new building systems are appearing, new needs are being declared. You know, it is a sector which also, where we find new things. Another thing is that BIM is developing. It's still a progressing field, okay? We are still learning these shortcomings and fixing them. Okay, it's not an established, mature system.
What happened to the first version?
Huh?
What happened to the first version file?
First version is retired.
Retired.
We
open the.
Yes, you can translate them. So this is a very good question. We have translators. So one of my colleagues, he was from China. We were sharing the same office. Hongjun Wang. So Hongjun in the US, he was working on that translation of IFC 2. Let me see. Here it says 2.3 was retired in 2005. Then we have IFC 4 was appearing. Yeah, 2016. 2.3. He was working on 2.2 to 2.3 translation. So the data translation, he was working on that. He was a computer engineer. So we were working together. Yeah, IFC version 4, we have this layered architecture. We have domains, okay, like building controls domain. We have plumbing, fire protection domain. Building controls, like building management systems, etc. Like controlling the doors, access, security, etc. Right? We have plumbing, fire protection, all these pipes, plumbing, fire protection pipes. We have structural elements domain, we have structural analysis domain. We have HVAC, heating, ventilation, air conditioning domain. We have electrical domain, we have architecture domain, and we have construction management domain. So these are the domains. We have interoperability layers, like shared building services elements, shared component elements, shared building elements, shared management elements, and shared facilities elements. So these are shared between these. Then we have core layer, control, product, process. So this is how we call them. It's the kernel we call. And then we have resources. Like we have a geometry resource. Okay, what's a geometry resource? Like we have rectangles, we have circles, we have lines. Okay, then we have geometric model resource, like a little maybe prism. Okay, geometric constraints, aligned, right? So it's geometric constraints. Equally divided into 5. These are the constraints, for instance. External reference resources, like a CAD file, for instance, or PDF file. Material resources, concrete. You see, we use different materials. We have concrete, wood, steel, right? Date time resource. We don't use that yet, but you can add dates, times to different phases of the project. Measure resources. Like we make measurements, we put them there, right? Utility, topology, quantity, property, profile, right? So I don't know if I showed you profiles, but you can create profiles and you can move them. At least you'll see them in family editing. Actors. Once we get to construction management, like we have worker, labor, foreman, right? We have engineer, architect. Costs, money, structural nodes resource, nodes, right? We have approval resources, constraints, representation, organization, definition, appearance, presentation. So these are all used for creating a common language. Okay, it's an open format written in non-encrypted text, so we can read the IFC file in a text editor. You just take an IFC file, put it in a text editor, you can read it. It's not, it's open format, which means that it's long-term accessible by both humans and machines. So you can basically write your own software to read the IFC file. Okay, so you can basically write a software that uses IFC file. You will meet him when you come to fourth year. We have a professor, Ali Murat Tanya Hoca. Okay, Ali Murat Hoca, when I was a student in the UK, he was a PhD student I was master's, he was PhD, and he wrote a software in Java that read the IFC file and that created a 4D animation for construction. Okay, so that was, and it was possible because IFC file is open format, you can read it. So IFC files are written in non-encrypted and encrypted languages, express data modeling language. Okay, we'll look into that. There's a header and there's a data block. And each line of code data block defines a unique object number that's reference to a specific object class and specific attribute values. So basically, this thing, okay, IFC wall, it is represented as this here. Okay? This is the way that the IFC is written. Okay, it's very simple. Here it says IFC project, and there is a number here, or basically an alphanumeric string of characters. Okay, it's called globally unique ID. Every element has a permanent digital fingerprint. So every little wall here has this ID. Okay, and then this ID is you cannot find another ID with the same similar code. It's created in such a way that in the software, each element has its own unique ID. And basically, if you read this with the software, you can create this. Okay? You just read this text and you can create this 3D model. And you can even create its material properties, its thermal properties, etc. if you want to add. Okay? So it's all possible. And the data is organized in a hierarchy. It's a tree. Okay? We have project, we have site, we have building story, we have space. Okay? So story in that regard is important. We created levels. You cannot create too many levels. You can only create necessary levels. So this is level 1, the upper one is level 2. This is level 0, level 1. Okay, upper one. If you have, let's say, half levels, etc., some students make this mistake. You cannot do that. You cannot have like level 1, level 2, level 3, level 4. No, this is level 1. Okay, this is the semantic of the whole thing. And of course, we have objects, entities, like IFC wall, IFC door. We have relationships, like hosting something. Windows is hosted in the wall, okay? Or wall bounds a room, okay? We can put many walls and say that these walls bound this room, okay? Or you have properties, like this wall is made of concrete. This wall has fire rating of that. Okay, or this door is made by this manufacturer. Okay, so you can put all these. Objects, relationships, and properties. So this is the idea. This is how the whole thing works. Okay, so we have objects, we have relationships, like the wall can host the window, and we have attributes, properties. And in IFC it is possible. So basically we have we organize it in a logical spatial hierarchy. Okay? So basically all physical objects are within a common general spatial structure. Okay? Which is project, as I mentioned, site, building, building story, space. So every BIM model has a project. Okay? Every project has sites. The site could be in one part. Let's say we are building several dormitories in that single project in O2. Okay, the project is dormitory project of 2026. Okay, and the site is there is a site in O2 campus, site A, site B, site C. Okay, each one is a different site. In each site we can have multiple buildings. In each building, we have multiple stories. We can have multiple stories if you want. In each story, we can have multiple spaces. These spaces can be rooms. These spaces can be zones. Okay, you define it. Door is not floating randomly in digital space. So, in that respect, when you think of it, it's very different than compared to Rhino, for instance. In Rhino, everything is floating in space, isn't it? It's normal because Rhino was for industrial engineering, industrial designers. We took it over because we like the curves. Okay. We like to create curves in Rhino. But Rhino, when I was a student, it was not taught in architecture. It was only taught in industrial design departments. And the classmates of mine who were into these, some students like, straight walls, some students like curved walls. The curved wall people would go and take this class from ID, okay? Because Refik Hoca was teaching at the time, Refik Toksöz, he's retired now, and they were learning Rhino there. So in Rhino we have objects floating in space. In SketchUp we have objects floating relatively in space, right? So you don't have levels, right? AutoCAD is already black hole. So, but yeah, with BIM we have this hierarchy. So yeah, the door is in a room. It's in a building story. It's in a building on a site. Yes.
Do we have any different site properties?
Yes. Yes. No. We can. There are project management tab. There you define the project owner, the site, the location, etc. So it's defined. You can do that. So, yeah, just like a Russian door, okay? Project site, building, floor, space, and the element is in that space. Door, okay? So that is the idea. We want to achieve that. And the spatial hierarchy in Express G is represented like that. Express G is representing the relation. It's a software representation format where we display relationships between objects. Okay. In Express G, like you have sites, then you have building story, then you have products. Products can be in a building story. They can also be on the site. They can be outside the building too, of course. Okay. Sorry, outside the story, like curtain wall, for instance. Okay, and we have this concept of IFC root. IFC root entity makes sure that at the root there is one object that is globally, uniquely identified. Okay, so that is the idea. This is the highest level abstract entity, IFC root. So you say that I have an object. First you give the ID to the object, then you describe the object. This object has this geometry. This object is this rectangular geometry like that. And this object is a door. You continue describing it from the root. Okay, this is how you do it. As a result, of course, you have ownership history. Who created this object? The first one that put the object there with this IFC root is the owner of the object. Okay? As an architect, for instance, when you put the door, all this happens immediately in Revit, for instance. It creates the root object and it creates the geometry, the properties, etc. It populates all that information around that object. Okay? And it starts with the globally unique ID. It's 128-bit code, like that. Okay? So, and then once it's created, many different things are added to it. Okay? So, the IFC root, in the IFC root we have IFC relationships, IFC objects, IFC project, product, elements, furnishing element, building elements, slabs, walls, windows, doors, standards. So this is what we call kernel, core layer. This is where we have product extension. Then this is where we have interoperability layer. Okay? So similarly, it's represented like that. This is the Express G specification of elements. And this is an example IFC file. It's difficult to see, but basically, we will make some exercises with that in the upcoming weeks. Okay? So, why is this important? So this is the last part of the lecture. PDF of BIM. Basically, this is this way we create a universal, reliable snapshot of the digital model with the IFC. Okay, it's like a PDF, and it preserves the 3D geometry and embedded data. It's a fixed snapshot of your design. It cannot be changed, but it can be used to view, query, and coordinate the information. Okay, you have different viewer software that can view the IFC, that can bring together IFC models. Okay, so basically you have your, like as I mentioned before, like your Word file that converts to PDF, your Revit or PLM file is converted to IFC. So from the live authoring to locked snapshot. Okay, it's a digital paper. PDF is called digital paper. So it was a big thing. Today it's a normal thing for you. But when we were students, PDF was a big thing. They would call it digital paper. And that's the idea. IFC is the digital paper of BIM. In a native BIM environment, we have many possibilities to change things. But once we export to IFC, it is frozen, okay? Static, non-editable state. So in Revit, we have the window as a parametric object. We can change things about the window. But once it is transferred to IFC, it's a frozen version of the thing. So it is used for coordination, review, and data exchange. Okay, so in Revit, you can still change the window. Once it is sent to IFC, it is window. It has the geometry, but it is fixed. It's not flexible. This is a good thing, because it prevents unauthorized edits by third parties. Okay? So the engineer cannot move your window. The engineer cannot change your wall thickness by them, on their will. If you give them your Revit file, they can change something and you cannot prove that they have changed it. Okay? But with IFC, they cannot. They have to rely on it. Okay? They cannot accidentally or intentionally engineers change it. It's read-only. As a model author, you have strict ownership and control. Okay? Frozen state basically gives you the responsibility or your total control of your native model. Revit model is yours. And you have different versions of your Revit model. It's yours. Okay? You just give your Revit model as IFC file to the engineer. They work on it. And if there's something wrong, they report back. Okay? So, yeah, it's a shield. I will tell you something interesting. When we were students, we were using AutoCAD, right? DWG files. So, when you take your DWG file to the plotter, you have your office, okay? You have a AutoCAD drawing file, but you want it to be printed. You don't have a printer in your office. You want it to be plotted, right? You take it to the company, and if you bring them your drawing file, there's a dilemma. What is it? Well, they can steal your documents. They can take your AutoCAD drawing, and they can make changes and use it somewhere else. How can you secure that? When I was a student, the way to secure that was DWF, Drawing Exchange File Format. So DWF was like PDF, but it was a CAD file, but they couldn't open it. They couldn't exchange things in it. So it was still opened in AutoCAD, and it was this file format that was locking it, okay? So that they cannot copy, because your name is there, everything is there, okay? So they cannot take a portion of it. They cannot copy your blocks. At that time, it was competitive advantage. Every office their own libraries of blocks, etc. So they didn't want it to be spread around. They were bringing their files as DWF files, okay? So it's very similar. You don't want to give your Revit file because it has your objects, it has your own, let's say, intellectual property. But if you give a IFC model, it doesn't hurt. Okay, and then that IFC model basically allows us to create a reference point for cross-discipline coordination. Okay, so different people let's say, stakeholders can work on that model and bring back their requests, okay? Because they can find out the clashes, and then they request a change, And this is like what we use there is the bin collaboration format, BCF, okay? Architect reviews the request and makes changes, and then updates a new IFC file. So it's just like, you know, you have this Word document, you create a PDF file, you send it to the people, they looked at it, they said, well, let's change this, let's change that. They make markup, they send it back to you, you look at the PDF file, then you open your Word file, make these changes, then send it back again as PDF file. Okay? So you don't want to give your Word file to these people. Like that. You know, there is a crash, the mechanical engineer says, you know, make an opening here. Okay? Then you don't directly edit, you basically use this to find the coordination of that problem. Okay? We will work on that. And then you go there in your model and then make that change. Okay, it's a lot of fun. You will love it. And of course, you reference in the federated model, as I mentioned, you have, for instance, structural engineer. They don't have to export their, they don't have to create their structural model in Revit. Okay, you did that because I want you to learn how to use Revit. It's a crash course in 4 weeks. You learn how to use Revit quickly, right? But in reality, like the structure elements, they could be created by the software environment like lect9. Okay? So they can use their own elements. And as a result, because they send it to us as IFC files, you know, even if they change something, we don't see that change happening immediately. Okay, we change it when it's issued. Okay, so basically, IFC also allows us to create issued versions. You basically release a version. Okay, that is the idea. Good. Let's summarize it. Yes. Basically, we want to rely on open and vendor-neutral data standard. Okay, so we don't want to rely on Autodesk, Graphisoft, or Bentley, you know, these companies' software versions, software file formats. We want to have an open, neutral data standard so that our project information remains interoperable, like it could be used by many different software environments, okay, directly. Accessible, you know, we can exchange that model with many people, they can use it, okay? And secured across multiple platforms through the entire lifecycle. So we can, that IFC file, we can open it, like, let's say, 20 years later, 50 years later, because there is some international body, Building Smart, who is maintaining that standard so that, you know, it can be translated, okay? So the OpenBIM approach is basically universal collaborative methodology. So OpenBIM is not IFC. IFC is one of the parts of the OpenBIM. But ISO 19650, which you are learning this semester, is OpenBIM too. So it's based on it's a standard way of working based on international standards organization. Okay? So we basically say that, well, I will create building information like that. Okay, with all these agreements between people, parties, descriptions, etc. Okay, IFC is an international standard data schema, ISO 16739. Basically, we use it as a digital container to organize and transfer both 3D geometry and semantic object properties between different BIM applications. Remember digital containers? We talk about digital containers. IFC is the digital container here. Okay? And of course, interoperability, it's a common machine readable language, so we can basically make sure that we can bridge the communication gap between diverse disciplines. Okay? We don't want to do manual data re-entry. We want things to be smooth between different people. Good. I think that's it. So, any questions? It's fun. We will have some exercises on IFC in the upcoming weeks. So I think I will share one of the tutorials to also using IFC. Okay? It's a very important thing. As I mentioned, now there is one project here we are waiting for the results for the tender to be published. But if it's taken, in that project, it's a huge project. They have 1,700 pages of description of the type of information that needs to be created for the project, and IFC is used extensively because you have structural engineering, you have mechanical systems, electrical systems, a very complex, huge project, one of the biggest projects in the world. Fingers crossed, hopefully, you know, if they get it, we will also be the consultants. And yeah, it's incredible. And for a project like that, this is how you work. Okay? Good, we have another tutorial for today. So do it and finish it. And I mentioned in the beginning of the lecture, I will prepare a dummy test, dummy quiz online to show you how the actual quiz will be like, with some simple questions and answers. Okay? In the midterm exam, we will have a theoretical part, which will be an online quiz here. And we will have also a practical part, which is basically a modeling task. I will ask you to model something, and then you will basically model it in real environment, and you will submit it. Okay? Good. So, see you next week.
Don't forget to